That's fine. I'll get it. That's fine. 6.2, number 9, 2 online. And it says, okay, whatever that means. Okay, let's try it again. Here we go. All right, 6.2, yeah, just come on in whenever you want to, that's fine. 6.2, number 9 in the book, number 2 online. Find the area of the shaded region, blah, 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 blah. All right, so first thing you want to do is draw a picture. And they've already got a picture there for you, but I'm going to draw another picture. Just to make it a little bit bigger after it orients. So, all of 6.2 have a mean of 0 and a standard deviation of what? 1. So basically the z-score. And they're giving you a z-score of 0.18. So this one, and there's 2 types of questions in 6.2. One, they give you a z-score, and you find the what? The area or the probability. What's the second type? They give you the area, and you find the what? Now, how do you know the difference between the two? Besides reading, the z-score is always what? 2 digits. The area is always what? 4 digits. So if you get a problem, and it has 4 digits, then you know it's an area. If you have a problem with just 2 digits, then you know it's a z-score. So the reason I draw this big picture here is so you will see that this is what kind of z-score, a positive z-score or negative z-score. It's positive, so it's right about here. And I'm exaggerating a little bit because I want you to see that it's to the right of your halfway mark. So that is 0.18. Now, there are 2 ways to find, actually there's 3 ways to find the area. And I'm going to go to a white page right now because I had an online student send me an email and says, how do I find the area and the z-scores? Even though I've covered it in another, I'm going to go over it again. 1. The table A2 consists of positive z-score table and negative z-score table. It is in your book. When you buy a book, you have a z-score in your book. Did anybody in here buy a book or a... Okay, where was it? Do you remember? It's in the front. Okay? That's one way. The second way is to go to Google and type in Triola. Somebody tell me what edition we own. Look at your book and tell me what edition. Anybody know? Okay. Does anybody have a book? Is it 12th edition or how much? 12?
But I know older.
That's fine. 12, whatever. I think it's 12th edition. I don't know. 12th edition z-score table. You type that in and it will come up and you have, of course, you only have 2, the positive z-score and the negative z-score. You print both of those out and you got it that way.
You do it from your homework.
Yeah, and the homework has them hyperlinked, unless the homework wants you to use the table here and here, and then we'll put it in there. Okay, so if you get a homework problem and it doesn't have the table with it, then it's wanting you to what? It's wanting you to find the table. 3. Hyperlinked with homework problem. In other words, they'll give you a hyperlink in the problem, and you click on it, and it pulls up the table. And then if you don't have any of these, you can use your what? TI-83. And what is it? Second VARS. Is it normal CDF or PDF? Normal, I think it's A, isn't it? Normal CDF. Okay? So there's 4 ways to find the area or the z-score. Now, if you're trying to find the z-score, it's what? 2? Or is it binomial? Okay, just making sure, because one is MPX and the other one is this, so you have to make sure. The other way is called inverse norm. Now that's to find the area. All right, what if you want to find the z-score? If you want to find the z-score, what is inverse norm? 3. Inverse norm is where you're finding the z-score. And we went through and done that in the class. You just have to look at the videos. But that's how you find, that's the 4 ways to find either the z-score or the area. These are the 4 ways. The table that comes with your book, the table that you can Google and print out, the hyperlink table that comes with the problem, and if the homework problem does not have a hyperlink, then they either want you to use the calculator or they want you to find the table. You use your own table. And then using the calculator. So that's the 4 ways to do it. So with this problem, I'll show you what we're going to do. Now it has the hyperlink here. This is probably a positive. This is a positive, so that's probably this one right here because I think the negative, read left to right. Negative would come first, then positive page. So I was thinking page 2 is probably your positive z-scores. I'm going to pull this up a little bit. I'll try to. There we go. And you want to find 0.18. So you take your handy dandy highlighter, and you know that 18 cents is a dime and 8 pennies, right? So a dime is right here. And 8 pennies. And they cross at what? 0.5714. Now, what have I told you about the table? It is from the what? Left. So that means that this area right here is what? 0.5714. Now, I don't know what the question's asking for, but I'm going to go ahead and do the right-hand side because people need to know how to do that because I'm getting questions from online classes. The right-hand side, as I told you in a previous video or class, is 1 minus the what? The left-hand side. So that would be 1 minus 0.5714, and that would be 0.4286. Somebody check me? And now you have both areas. You have the area up to 0.18, and then you have the area above 0.18. So let's take a look at our handy-dandy question and see what it says. The graph depicts, find the area of the shaded region. So it wants this, so that's 0.5714, and that's the answer. Okay, how do you do it with the calculator? Well, let's pull up the handy-dandy calculator. You pull up your handy-dandy calculator and you hit second, VARS, normal CDF, and type in, look at your picture. Let me find my picture. Okay, there it is. All right, what side, what is this end right here? Negative what? Negative infinity, right? Because, look, hold on a minute. I don't like this. Let me take this. Good, it worked. Copy. I can't win. I'll just draw it again. All right. If you remember from grammar school, the number line, y'all remember the number line? This arrowhead is called what? Negative infinity. And this arrowhead is called what? Well, you can't put negative and positive infinity in the calculator because they don't know what infinity is, neither do I. All right? It's just one plus another number to us. So you have to give it a number. So I tell students, when you're dealing with normal CDF and you need to put in the negative infinity, put in negative 9999. You put in negative 10,000. You can put in negative 1 million if you want to. I don't care. Just don't put negative 5. Okay, because that's not going to work. You got to put 4 digits, negative 10,000, negative 9,999. Put a big number. And then up to 0.18. So, you put in second, bars, number 2, which is normal CDF. Y'all have to, I've got them things in my head so I can't remember what they say. Normal CDF, and then type in parentheses negative 9999 or negative 10,000 or negative million 2.18, and then hit enter. We're going to do that now. And I put, oops, forgot my negative. Oh, I suck. Let's see, where's the negative? There it is. I don't use a calculator very much. I like to make change. When people need change, I like to be able to make it. 2.18. 0.5714. That's what we got. It's a miracle. Now, will there be variations between the calculator and the table? Yes or no? And what have I told y'all about that? That the MyLab Plus, what does it do? It makes what? It makes adjustments. It gives you the answer in, and hold on, this one probably won't do it, but when you type in the answer, it's going to give you the answer, and then it's going to say, it's going to have 2 numbers, and then it's going to have plus or minus 10 to 100 thousandths. And the 2 different numbers, one is with the table, and the other one is with the calculator. And you'll see a difference probably in the thousandths or the 10 thousandths. You'll see like a different digit, like 1 digit off. Okay? And that's how you do that. So you feel good about that one? That's 6.2. All right, let's go do another. The next one, 6.3. Let's see, that's 6.5. That's 6.3. Here's 6.3. 6.3, number 9, or number 21 in the book, number 9 online. 21 in the book, number 9 online. A survey found that women's heights are normally distributed with a mean of blah, 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 a branch of military, okay, they give you a mean and a standard deviation. What are you supposed to do? Draw a picture. So go ahead and do that. All right, since I'm doing this for the online students, I want y'all to take the calculators out. Notice I told you to use your calculators. That means you should. And take 63.7, add 2 of these, and then take 63.7 and subtract 2 of them. And tell me what you get. We'll go to the right first. Add 2.3, that's going to be what, 66? I can do that. Then 68.3, y'all check me. And y'all gonna have to help me here. 61.4. I can't subtract 42 cents. And what's the other one? I'm not even gonna try it. Huh? Thank you. All right, so there's our picture. So that takes care of this. A branch of the military requires heights to be between 58 and 80. So between 58 is down here, and what? 80. So they want to find that area between 58 and 80. Everybody with me? So you take your biggest area and you subtract your what? Your lowest area. And that area is like this right here. That's your, so this is the, and it's hard for me to show this because I don't want to overlap it. But here's your small area right here. And your big area is this area right here. So that's your big area. Now if you take your magenta area, which is your big area at 80, and you get a number, and then you subtract the area of what? The green, the area at 58, then you'll have your area of blue, which is your area in between. Area between 58 and 80. It'll be whatever that is right there. So, first thing we have to do, if we're doing this by hand in tables, we have to change 80 and 58 into a what? No, the column wall. Okay? So my area of 80, we got to change that 80 into a, so 80 minus 63.7 over 2.3. Somebody give me that. It's going to be a positive number. How did I know that? Well, it's way over here. So what is that? Give me 2 digits because this is Z-score. 2 decimal places, sorry. Point. No, it's not 0.71.
Oh, it is.
Good
It's
gracious.
7.086.
7.086. So 7.09. Right? Okay. Now let's find our Z-score here at 58. I'll do it in green. I know you won't be able to see it, but I'm trying to do it color coordinated here. So 58 minus 63.7 over 2.3. What's the biggest problem students have here? They switch the top because they don't think, they start thinking. They say, oh, well, it's not supposed to be negative. Yeah, it is. It's to the left of this big line here. It's negative. So you leave it alone. Don't start thinking. And somebody give me that negative number to a 2 decimal places. 2.48. Okay, so you got your z-score there. And you got your z-score here. So now you look up your handy-dandy table, and they give it to you. So let's go to the 2.48 first. I'm going to go to a clean page. Oh, I can't do that. Here we go. Negative 2.48. Negative 2.4, 0, 1, 2, 3, 4, 5, 6, 7, 8. 0.0066, is that what y'all got? So that goes here. 0.0066 is our green area. The green area right here is please work with me. 0.0066. Now, does that make sense, common sense wise? Yeah, because this is a very small area because it keeps converging onto this axis here, and it just keeps getting smaller and smaller and smaller. So yes, 0.0066. And now let's do our, what was the other number? 2 point what? Or 7 point something? What was it?
7.09.
We don't even have to look it up. Why? Anything above 3.5 is what? 0.9999. I know y'all think I'm a lunatic. I'm trying to get all everything, trying to do all this in my head. 0.9999. So if you're doing this by hand and by the tables, you find 0.9999 minus 0.0066, 0.99 what? It's a miracle. 0.9933. And that is the area between 58 and 80 inches. So, how many meet that requirement? 99.33%. So you put 99.33. Okay. Now, it says, are many women being denied the opportunity to join the branch of military because they are too short and too tall? Why did I take those out? You got 99% of the population. Although in today's society, we probably would be discriminating against somebody because we are in the discriminatorious time that we've ever been in the United States history. I mean, you could go out and say somebody's got big eyes and they say, oh, I'm feeling discriminated against. I mean, we've gotten crazy. But anyway, 99.3% of the population is covered. So these two don't. No. I would say C. No, because the percentage of women who meet the height requirements is fairly small. That's not right. So that's not right. So it'd be C. Okay, for the new, let's see what it says. If the branch of this branch of military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what would the new height requirements be? Well, this is another problem in itself. So we're going to take our, I'm going to get a white board here because y'all going to have to help me. Go ahead and write B down. If you haven't got it written down, just write B down and make sure you got those other numbers because I'm going to need the mean and the standard deviation. Well, I'll tell you what, let me just do this. Let me just take the tool. I hate to know what it's called, but there it is. And we'll just take this, take our handy dandy tool and take this out. Save. And take our handy dandy whiteboard and insert the y'all are impressed, aren't you? I knew y'all would be. All right, there's our question. Now, what do? Well, first of all, you draw a picture again. All of these problems you need to draw a picture because it helps you get acclimated to the problem. Because what's the first thing people are going to do when they see this problem on the test? What are they going to do? I'm going to the next problem. Why? Why? You hadn't even read the problem. Why are you going to say that? Come on, spit it out. Because what? Too long. So you're going to wait until it lasts. So after you get over doing the other problems, you're still going to have to draw a picture because this helps you ease the anxiety about this problem. So go ahead and put your 63.7. What was our numbers this way? 66 and this way and Lauren, head downstairs. Hello. Okay, I'm gonna send my daughter down. She'll meet you downstairs. Thank you. Did y'all hear her? Wow. Okay. Now, remember, what is this area? Remember your rule of thumb? I mean your empirical rule? This is 2.5%. This is 2.5%. This is, I can't remember, this is 34%. This is 34%. Somebody tell me what these two are. I always forget them. 68 plus 5 is what? 73, 70, 12 or 13.5. Somebody tell me what it is. Anybody remember it? What's 73 from 100? 27, right? That'd be 13.5. All right, now, the reason you put the empirical rule in there is so you can draw your lines. All right, now what does it say right here? The shortest what? So you know this is the shortest 2.5%, so where would 1 be? Right here? Right about there? I mean, I can draw it larger if you want to. 3 standard deviations be down here. Let's go ahead and do another standard deviation. What's 59.1 minus 2.3? 56.8? What is it? All right, you know this is 2.5%, so what would half of it be? 1 point something? So, I'm going to put that right there. I'm going to put another color. Let's do blue. So here is our 1% of short people. I'm sorry, 1% of vertically challenged people. Point, say 1% would be 0.0001. Everybody with me? Ain't that 1%? Okay. And what about the other end? Top 2%. 2% would be, let's do it in magenta. This is 2.5, right? So 2% would be right in here. Everybody with me? And all you got to do is find what marks this point. Common sense tells you what? It's going to be above what? 68.3. What does common sense tell you over here? It's going to be about what? 57, somewhere in there? There's pizzas. Y'all go ahead and get something to drink if you want to.
I'll get the receipt.
There you go. I'm gonna get me a piece of. I'm not allergic to anything, and I sure ain't no vegan or vegan or whatever you call it. Whatever.
Bacon.
Bacon. Hurry up, these things are hot. I didn't know it was that hot. The U.S. just took it out of that gum.
Yes, Daddy, it's pizza. You complained if it was cold.
It is hot. Bottom of that sucker's hot. Huh? Yeah, go ahead. Oh, it's right down here in the middle of the hallway. Just walk down and you'll see it. And let's see. Need to get a z-score here. So we need a z-score here. And we need a z-score here. So find those z-scores. There's some silverware napkins up here too. Whew. You might have to get one because ain't nothing worse than eating a piece of pizza and it be hot and that cheese get all over your chin. Not gonna get a fork. Yeah. So you're going to have to look for 0.0001 in your table, and that's going to be what kind of a z-score? Negative. And then you're going to have to get another z-score of positive, and it's got to be for 2%, so you got to look for 0.9800 for 98%. Now, I need to go through that because some of y'all are going, what are you talking about? Well, with this z-score right here, it's on the what? What's this area on? It's on the left-hand side, isn't it? So with this one, the table gives you the left-hand side. So somebody look on the negative z-score table and tell me what z-score is negative 0.0001. It should be 3.5 or something like that. 3.58. Okay, so 3.5. Okay, so there's that z-score. Actually, I should have put it over here. My bad. Yeah, I should have put it over here because that's too. Yeah, I should have put it over here. But anyway. And this z-score is 98%. Why 98%? I thought you said top 2%. Yes, if this is the top 2%, what's on the left-hand side? If that's 2%, what's on the left-hand side? 98%. So you got to find 0.009 or 0.9800, and somebody look on your positive z-score and tell me what 0.9800 is. How much? 2.06. 2.06.
Then it ain't got like 98 even.
Okay, well, let's look at it.
Yeah, I got 9803 and then the next.
Okay, what's
9798.
okay? What's closer to $98?
The 9798.
That's what you use. What's 97.98?
205.
205. All right, so we found, for those of you who just come back, we found our z-scores for 98%, z-score at 98%, and z-score at 2%. I'm sorry, 1%. Now let me reiterate. The reason this is the z-score at 98%, if you use the graph, if you use the table, the tables will only give you the z-score for the area on the left-hand side. So if you're looking for the top 2%, what's this left-hand side at 2%? 98%. So you got to look up the 98% z-score. You got to remember that. Now, remember our two formulas to find a z-score. X minus x bar over standard deviation. Or if we want x is equal to Oz plus what? Oz plus mu. How do you know what we're trying to find? Well, do we have a z-score? Right, here we go. So we don't need this. So that means we're going to be using what? This. We're going to be using this right here because we already have a z-score. We don't need to figure a z-score. We already found it. So on the blue side, x is equal to Oz, well, O, that's sigma, is 2.3 times 3.5 is our z-score. Is that negative?
Yeah.
Yeah. Plus 63.7. Somebody crank that out for me. Just give me the whole number to 2 decimal places. Or 1 decimal place. Why? No, that's what our measurements are given in. Where's Walt, Warren? Was he going to eat? Would you tell him the pizza was here? Okay. Somebody give me that. Well, negative 7 or negative 8 plus 63.7 is 58 something. What is it? 54 point what? Which is 55 inches. I don't know how they want the answer, but that's 55 inches. So this is 55 inches. It's supposed to be over here. I didn't draw the line at the right place. Okay? Now y'all do this one. Oz plus mu. And then we'll check our answers. What's wrong with him?
Oh, was trying to get him.
Is he mad? Okay. So, Oz is, or O is 2.3 times 2.05 plus 63.7. And 2 times 2.5, that's going to be 2.5. That'll be 68 something. What is it? 68.42 or 68.4 inches. So 68 inches and 55 inches are your new heights. So let's go over and see. They probably want it to the whole number or to the first decimal. So that'd be 55 and 68.4. Yeah, 55 and 68.4. Okay, it was supposed to be between those two numbers. I got something wrong. Y'all help me out. Yeah. That number is supposed to be right here is what I thought. It said the lower 1%. All right, do the math again. It's supposed to be negative 3.5. What's 2.5 times negative 3.5? And then add that to 63.7. What do you get? Then that means our area is wrong. We need to look it up. Give me a second. Where's my... Oh, really? All right, the percentage of women for the first one was 99 point what? 33. And then no, right there. All right, let me go back to point -3.5. Okay, then I'm doing something wrong or I've read something wrong. It says, except the shortest 1%. The last time I checked, that's 1 over 100. .01. That's it. 0.0100. I wrote it down wrong. I'm sorry. Right here, that's supposed to be 0.0100. I didn't think that was right when I wrote it down. I thought that was odd. 0.0100. That would make a difference. 0.0100. 0.00. Somebody look that z-score up. Well, I'll look it up. If I can find it. 0.01. So that'd be 0. 0.01 is 0.4960. Is that right? Oh, that can't be right. Oh, I'm looking at the area. Thank you. 0.01. 0.0100. 0.01. Okay, what's closer? 99 cents to $1 or $1.02? 99 cents. So that'd be negative 2.33. That's a whole lot better. So my mistake, I made a mistake. I'm sorry. So that's going to be negative 2.33. So now you need to recalculate. Negative 2.33. Now we change this here. Negative 2.33. Somebody tell me what you get.
57.87%.
I'm sorry, 50 what? 8? 57.9. That looks better. 57.9, which is 58. And I was right here because my drawing was right, so that makes me feel better. So that's equal to 58 inches. Change that to an 8. Sorry about that. And the answer we said is 58.0. And what was the other one? 68.4.
Change it to 57.9.
Well, I thought y'all said it was. Okay, 58.3. What did we get? Okay, well, there must be something wrong, so let's go back and check it. Let me use the calculator and see, because evidently there's something not right. So take my handy dandy calculator and take negative 2.5 or 2.5 times negative 2.33 and add to 63.7. 57.8, that'd be 57.9. But now you must be using another z-score, or they did it by a calculator. Somebody take a calculator and do between negative 2.33 and 2.05. Let's do that. Second, enter. No, I'm thinking, hold on, I got to do inverse norm. That's what we need to do. Second bars, inverse norm, and that's going to be 0.0100, close parentheses, 2.33. All right, now let's do the other one, inverse norm of 0.9800, right? 2.05. Okay, we've done it right. Evidently, I don't know, unless there's something I'm missing. They may be taking 2.326. That may be what they're doing.
If you go back to the question you have, the thing like we can walk you through it.
Well, I know. I'm just hold on just a second. Negative 2.32634777 times 2.5 plus, what is it, 63.7? Still not getting what they're coming up with. So we're going to go back and look. I don't want to have to answer all them questions, but I'm a little bit, I think this is wrong. I think this one's wrong. I think it should be 58. What did we say, 58? That's what I think it should be, but let's see what they did. You don't have to answer all these questions. All right, is that the first one, 58? If we get 2.48, okay, that's right. And this one,
Priority 1 message coming in on secured channel.
okay, at least we know we did that part right. Okay, did we get 99.34? And B, we got that right. I don't care about that. Go away. All right, is that not 2.33 is what we got? Where did they get 2.3? We got 2.5.
Here, I just had you 2.3.
Well, where did I get 2.5? That's my mistake. My mistake. I just changed 2.3 into 2.5. That's my mistake right here. I just decided to change the problem
Where did we go?
right here.
2.3.
It's supposed to be 2.5 right here. Or did it again. It's supposed to be 2.3. See right here? I changed that to 2.5 for some reason. Okay, so what do you get? 58.3. So we were doing it right. I just changed the numbers. That's all, you know, just something teachers do. 58.3. Sorry about that. Y'all didn't say nothing. We got, yeah, that's, but I don't know why I changed that. Maybe there was something that told me 2.5. I don't even know where oh, I know where it came from right there. That's where it came from. I bet you I looked at that or something and I put a 2.5 there for some reason. Why do we do the things that we do? I don't know. I suck. I should quit, shouldn't I? All right, so everybody good with that one now that we figured out why it's screwed up? It's screwed up because I wrote a number down that didn't exist. All right, let's go to another problem. That's 6 point, let's see, we did that one, that's 6.3. Now we just got 6.5. I'm going to take, let's see, delete. Okay, and where's the other one? We did, that's 6.2. We did that one. There's a 6.3. All right, this is 6.3. This is number 7. 17 in the book, and number 7 online. All right, write it down. Assume that adults have IQ scores that are normally distributed with a mean of 105 and a standard deviation of 15. Find the third percentile. That's what P sub 3 means. Third percentile. In other words, the area is 3%. Draw a picture. The reason you should draw a picture is because it helps you. What's the mean? I'm sorry, what? And what's standard deviation? So that'd be 120 and 135 and 90 and 75. And they want to know where is the third percentile. Which way do we read? So the third percentile, we know this is 2.5 right here, right? So the third percentile will be where? Right in here? And this blue area represents 0.0300. Don't write it down wrong like I did in the last one. So let me ask y'all a question. What are they giving us? Are they giving us the z-score and we find the area, or are they giving the area and we find the z-score? Area, find the z-score. So go to your handy-dandy table, or look at your table for an area of, that's not the z-score table. I'm just not hitting on all four cylinders today. Table A2, find the area of 0.040300, and that'll give you a z-score. Or you do your handy-dandy TI, you do second bars, and then you do inverse norm, parentheses 0.0300, and either one, tell me what you get. All right, common sense. Does that fit? Yes, because this is 0, this is 1, this is 2, this is -1, this is -2. Where are we? Near -2, which is -1.88. So you quit now, right? No, that's the first part. What do you do next? Well, you got that 1.88. So do we have a z-score? Remember, you've got two formulas to use. Z is equal to x minus x bar over standard deviation, and x is equal to Oz plus mu. Which one do we not need? So that leaves you with this one. Plug and chug. X is equal to 15 times -1.88 plus 105. Somebody crank that out for me. Let me ask you a question. If you was to bet $100 on it, what would you bet? Without calculating. Just what would you bet? 76, Hubert. Yeah, probably. Thank you, class. Thank you. What'd you get? How much?
76.9.
It's a miracle. along the same, I would have really estimated 77. And that is your number.
I'm gonna have 8.
Set me up, that's fine, just set me up. That's a good test question. Why is it a good test question? Because it's short and sweet. I don't like, that last one we did, that's too much for a test. I know I probably have it on there, but I don't know if I do or not. So, what did we get? 70 what?
6.8.
Okay. Now, the problem that I want to pull up, I want to pull this test question up, and then I'll pull your test question up. No more coughing in class. Let's see. This student sent it in, and it's a, I don't know, it's an old question, but I still want to cover it. Find it. This is an old question, but I still want to cover it. There. Write that question down. This is a MPX question, but I still want to do it. 5.3. Says when someone buys a ticket for an airline flight, there is a 0.09 probability that the person will not what? All right. When you see one of these problems, and I know it's chapter 5, but when you see this problem, the first thing you should think of when you see that not show up, what is the complement of not showing up? Showing up, right? So, when you see this right here, first of all, you know you're going to use that number because what does it have right beside it? Okay, so you know you're going to use it. So the first thing you say is, first thing you should say is, okay, well, if there is a 0.0973 probability of not showing up, then we have a 0.9027, somebody check me, probability, excuse me, of what? Showing up. Now somebody tell me what that is. Complement, Hubert. That's right, class. The complement of what? Well, what's the complement of not showing up? And what's the complement of 0.0973? Because they both equal what? If you add them together, they equal what? Which is the maximum probability. Okay? So, that part of the question gives us that. Now, a certain jet can seat 23 passengers. So, we got a jet here. Alright? And it can seat 23 people. So that means the airline is going to sell 23 what? Okay. Is it wise to book 25 passengers? .9027. And X is equal to 23. Now, take your binomial, what is it, binomial CDF or binomial PDF? It's A. Second bar is A. What is A? Somebody tell me.
PDF.
Is it PDF? Second bar is binomial PDF and type in NP and X. And what's special about NP and X? You have to type them what? In order. So type in 25. P is 0.9027. And X is 23. And somebody tell me what that number is. Point what? Should be the answer. Okay, make sure I did this right. Somebody take 1 minus 0.0973. I got this to come out right. Why ain't it coming out right now? What'd you get? 9027? Second bars. I can't remember if it's binomial PDF or CDF. I think it's CDF. And that'll be 25, comma, 0.91 or 0.9027, comma, 23. There it is. 0.7141. 0.7141. Now what is that? Somebody tell me what that is. You got a 71% chance that what? Of overloading. Is that a wise decision if you are a ticket person? No. Okay. Now, what's the if that is for everybody showing up. That is the probability for everybody showing up. So, what is the complement of everybody showing up? Be 0.29 something. So take, what was it? What did this come out to be? 0.71. 7 for what? 1. So if you want to find the probability of them not showing up, then take 1 minus 0.7141, and that's everybody not showing up. And tell me what that is. Point what? That's your answer. Is either one of these your answer? Yes. Because the question is asking you, is it smart for you as a ticket agent to sell 25 tickets with a probability that, that you have a 10% probability that people will not show up? That's what it's asking you. I wouldn't, unless you want to buy a ticket, because I guarantee you if you overbook and you didn't crunch out the numbers and you have a 71% chance that everybody on that flight's going to show up, what is your boss going to tell you? Yeah, or you pay for the tickets. Now, do I agree with this .2859, the way they have it worded? No. I would say, whatever this says right here, it is not a wise decision because you're having a 71% chance that what? That everybody's going to what? Show up. Now, anything less than 50%, it's okay. But you got a 71% chance. That's almost that's almost 3/4 of a chance. I mean, I wouldn't bet on it. Okay? Or I wouldn't make that decision. But that's that question. What's your question? Let me just pull it up. It'll be easier for me. Okay, hold on. Let me get out of this. Which test? 086, review number what? 14. Okay, uniform distribution. Remember I gave y'all 2 questions at the beginning of the chapter 6. What's the difference in uniform and normal? What is uniform? And what's the only thing that's uniformly distributed in our time? Time. In other words, it doesn't change for who? Anybody. A statistics professor plans classes so carefully that the lengths of what? Per. Anytime something is real good and real precise, they say what? Per. Anytime you got something that's not done right or not done correctly, it's a him. Are uniformly distributed between 46 and what? 56 minutes. So what's the base of our rectangle? The base of our rectangle is what? 10, Hubert. That's right, class. So what is the height? Well, we know that the middle is, the area under this curve is 1.000, so area is equal to length times width. 1 is equal to 10 times width. Divide by 10, divide by 10. Length is equal to what? 110. That's part 1. Remember, there's 2 parts to this. Okay, there's the first part. Really? All right, the second part. We got a box here, and it's 10 units long and 1/10 height. And you want to know what is the probability of a class running between 51.25, so 51.25 is right here, and 51.75. So what's the distance of that little strip right there? Well, what's the difference between $51.75 and $51.25? 50 cents, 0.5, right? So you take 0.5 times 1/10. Now please do not do this with a calculator. Why? Because what is 5/10? 5 over 10, that's right, class. And what's 5 times 1? Or what? Can you do something with these 5s and this 10? What can you do? What do you get? 1/20. Well, I don't know how to do that with a calculator, Hubert. Well, divide by 2. Divide this by 2. Divide this by 2. You get 1/2 over 10. And what's another way of writing 1/2? 0.5 over 10. And this is divided by, so you move it one place. Look over there. 0.05. I bet if you did that calculator, I bet you get 0.05. What's the 6 cents for? Look over there. We got it right. And we didn't even use a calculator. So, what do you do first? 1, you find your height. And then once you find your height, what do? You find your new what? Your new base. And then once you have your new base, you multiply your height times your what? Your new base. And then that gives you your what? Your area. Let's go through it again. What's given? Well, the area is given. You shouldn't mess that up. Okay? This is given. So you have to find what? The height. Then once you find the height, you put the height here, you put the base here, and then you find your new base. Well, really, you don't have to draw this strip. All you have to do is subtract these two, and you come up with 0.5, and you multiply 0.5 times what? 110. That's what we do right here. That's all there is to it. Question? Does that help, Ms. Cowart? While we're at it, while we got your test pulled up, let's look at your other ones. Because that way other people can see what the test looks like. I hope you didn't miss one of the easy questions. All right, try that one. 6.2. Six point 2.23 in the book. I have no idea what it is online, but assume that the readings of the thermometer, this is a 6.2 question, so it's 0, 1, and 2. So zero, 1, 2, negative 1, negative 2. That takes care of all this. Find the probability that randomly selected is greater than 2.09. So I'm going to take my blue marker. I want to know this. I want to know that area right there because this is 2.09. So we take our handy dandy calculator. We've got to find this area right here if we use our table. Because the table only gives us the what? And to find the right hand side, you got to subtract the left hand side from 1. So if you're doing it by the table, you go to your handy dandy positive table and find 2.09, 2.00, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0.9817. Everybody with me? And that's 0.9817 right here. That's from there. Oh, sorry. Hold on. Oops. From here to infinity is, so that point right there is 0.9817. So at 0.9817 is this area right here. Then to find this area, we subtract 0.9817 from 1. So we take our handy dandy 1.000 minus 0.9817 Now, what's a dollar minus 98 cents? 2 cent, Hubert. That's right, class. So you're going to have less than 2 cents because you got some extra cents over here. So it's going to be 0.01. Dang on what? 83? And that is your area in blue. So you're probably talking about this. And then, look at there. 0.0183. Then you feel good about yourself. Right? Or you could quit school. All right, you try that one. Draw a picture first. No more sneezing. You already got caught yawning.
You have a work email.
Assume that the ratings of the thermometer are normally distributed. Again, we have zero, one, two, negative one, negative two. That takes care of all of that. Assume 2.2% of the thermometers are rejected because they have readings that are too high. Well, 2.2%, this is 2.5 right here, correct? The 2.2 would probably be right in here. And then the other 2.2 over here. And even though this doesn't end, I'm just kind of moving it down so you'll understand that if this is 2.5, then 2.2 is shy of 2.5. So we got to find this z-score because we're given an area, and we got to find this z-score. Now, what do you notice about both of these areas? They're what? They're the same. They're symmetric. So you can use that to your advantage if it's symmetric. Pretty much. So the easiest one to find is which one? This one, because the tables are on the left-hand side. So I would find this one. So we go to our left side table, and we got to change this. 1, 2, so 0.0220. So our 2.2% is equal to 0.0220. And why'd I put it in 4 digits? So you would look for an area of 0.0220. So we pull up our handy-dandy table. 0.0, we're looking for $2.20. $2.20. What's closer to $2.20? Oops, that's the wrong one. $2.20, $2.20, where did we go? $2. Right here. What's closer to $2.20? $2.22 or $2.17? $2.22. That's only 2 pennies off. So this is our number, negative 2.01. Is that what y'all got? Negative 2.01. So our z-score is negative 2.01. Now, since this is symmetrical to this, in other words, if those two percentages are the same, then all you do is the positive and the negative. If it's not, then you have to look up the other one also. So, negative 2.01 and what? 2.01. Just be careful. If they're not symmetric, you can't apply that rule. You have to look up the other one. All right. Assume that readings of thermometers are normally distributed, blah, 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 blah. Find the probability that the thermometer reads greater than negative 1.37. Greater than negative 1.37. And they want to know negative 1.37. Well, negative 1.37, I'll do it in blue. Negative 1.37 is right in here. And they want to know it's reading what? Greater. So which one of those looks right? That one. So now, you know you got negative 1.37 here. So find the left-hand side and subtract it from 1, and you'll have the what? Right-hand side. So, negative 1.37 negative 1.3, 0, 1, 2, 3, 4, 5, 6, 7. I got 0.0853. So this area is 0.0853. So if I want to find the right-hand side, I'm going to take 1.0000 and I'm going to subtract 0.0853. Now, what is $1 minus 8 cents? 92 cents. So you're going to have less than 92 cents because you got some extra change here. So 9, 1, dang old 4, 7, and that is that area right there. You got it right. This stuff ain't hard. Unless you what? Make it hard. Or unless you just give up. Which giving up is good. It's real easy to do. Alright, now this problem, okay, go ahead and look at it. It says the length of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. Find the probability of pregnancy lasting 308 days or longer. If the length of the pregnancy is the lowest 3%, then the baby is premature. Find the length that separates the premature babies from those who are not premature. So you got two parts. You got an A and a B. Once we finish these test questions, we'll go over those other questions that I've got. And y'all just free to leave and go if y'all want to, okay? If you need to go to the restroom or get water or get something to drink. But we're going to be here for a while to answer all your questions. Of course, the most important thing is to what? Draw a picture. All right. 268, somebody add these for me because I'm not going to add them. What's these two over here?
283, 298.
And how much?
253, 238.
All right, and they want to know 308 days. So I'm going to take my red marker, take on Superman colors, take on 308 days. We want to know that red area right there. And we know that this is 308 right here. Uh-oh, we got to find the what? What do we got to find if we want to find an area? What do we got to have? Z-score. So Z, work with me please. Z at 308 is equal to 308 minus 268 over 15. Somebody tell me what that is. We know it's greater than what? 2, right? Remember? 0, 1, 2, -1, -2. So we know it's greater than 2. 2.67. So go to your handy-dandy table and find 2.67. 2.6, 0, 1, 2, 3, 4, 5, 6, 7. I get 0.9962. What do y'all get? And that is what area? That's the blue area, 0.9962. That's this area right here. Okay, but we don't want that area. We want the red area. So, to find the red area, 1.0000 minus 0.9962. And what's a dollar minus 99 cents? 1 cent. So we're going to have less than 1 cent. And what's less than 1 cent? 0 cent. So 0.0038. And that is your red area, 0.0038. Now, is this just a coincidence, 308 and point? Yeah, that's just a coincidence. Okay, so that's that part. You just aren't going to work with me, are you? No, I don't think you were. Let me try this. Okay, so that's that part. Now, it says, if the length of the pregnancy is in the lowest 3%, then the baby is premature. So, let's just forget about this part that we just did. And I'm going to draw another picture over here. That's part A. And part B. Draw another picture. And 268, 283, 298, 253, and 238. Now, what do we know about this little block right here? Right there. We know that represents what? 2.5, right? So what would 3% be? 3% would be right in here maybe? So we're going to call this our 3%. Okay? Now, 3% is 0.03 what? 00. So, hey, what is this? That's our area. So we got to find a what? Z-score. So do it. Take your handy dandy calculator and let's do it for those people at home that need to do it with a calculator. Let's do inverse norm. So second bars, clear. Second bars, inverse norm, what? 0.0300, close parentheses. I get negative 1.88. Is that what y'all got? Yes, Hubert. Thank you, class. So this spot right here is negative 1.88 z-score. But that's not going to do us any good because we've got to have a what? A number like 200 and what? 240 pounds or 240 days. It's going to be between 238 days and 253 days. Looks like around 240. So negative 1.88, that won't tell us jack. We need to know how many days. So what is 1.88? That's a what? What is that? The z-score, Hubert. That's right, class. So if we've got a z-score, we don't need the z-score formula, do we? So what's the only other formula we have? Oz plus what? Oz plus mu. We don't need the z-score formula because we already got a z-score. So somebody take take 15 times negative 1.88 and add it to 268. Tell me what you get.
239.8.
Which is what? What did I say it was? 240. And I don't know. Yeah, that's right. You got it right. So that's how you do that question. The good thing about these videos is you can rewind them. Question. Does that help? Now, Miss Coward, I just did your test for you. You should make 100 now. Now, was there any before that? Let's see. There was? Let's see.
You started out at 14.
Okay, well, let's see. All right. What?
I said then cut off questions.
Yep. Try that one. Well, this is like the one we did a while ago. Are they symmetrical? Yes. So find the left-hand side. So what is 2.9%? .9 is rewritten, 2.9% is 0.0290. So what is that? That's an area. You got to find a what? Is it going to be positive or negative? Well, that's 2.5%. So yeah, it's going to be negative. So we go to our handy dandy formula table and look up what?
Minus 1.87.
Okay, that's good. I'm looking to see. Let's see. We want $2.90. $2.90. $2.90. Here we go. $2.90. Well, where'd I go? There's $2.94. Oh, here it is. Okay. Here's $2.87. And here's $2.90. Okay. What's closest? $2.87 or $2.94? 87. So it's 1.90. Negative 1.90. Is that what y'all got? Did you use a calculator, Miss Joshi?
Yeah.
Okay. So see, there's your difference. And it's going to have two answers. You'll see in just a minute. So I got negative, I done forgot.
1.98.
Thank you. negative 1.90. So let me get rid of the handy dandy chart. And I'm going to do this. So our z-score here is negative 1.90. Now, if you do, this is a table. If you do the calculator, and you do second bars, inverse norm, and you do 0.0290, what does it give you, Miss Joshi?
Minus 1.8956.
1.
1.8956.
Okay, now, even though the two numbers are basically the same, you're going to get a different answer as far as the tens and the hundreds, thousandths. The 10 thousandths, 10 thousandths. The 10,000, the hundredths, the thousandths and the 10 thousandths are going to be a little bit off because of these right here. Okay? And you'll see that in your problem. So, now, there's your 1.9 and positive 1.9 because these two are symmetrical. So if these two are symmetrical, then that means that these two are symmetrical, just different signs. So your answer is negative 1.9 and positive 1.9.
Will we run into what I mean, not symmetrical?
Yes. And then you just look for the left-hand side. I'll make one up. Find me a z-score that represents the bottom 3% and the top 8%. And we got a mean of 100 and 105 and 110 and negative or 95 and 90. So you got a mean of 100 and a standard deviation of what? 5. Okay, and I want you to find the bottom 3% and the top 8%. So the bottom 3% would be right here. 0.0300. And the top 8%, this is 2.5, so maybe right in here. 0.0800. Right there. Tell me what those numbers are. Why you got two different plates? Now this is a 6.3 question because the mean is not 0 and the standard deviation is not 1 or 2 or 3. So that's why I did this one, because this is one I would probably give you on the test. So somebody do second bars, inverse norm, 0.0300. What do you get? Negative 1.88, and that's the z-score right here. And somebody do second bars. Be careful here, because you're not gonna do 0.8. What are you gonna do? You're gonna do 90 what? 9200. Why? Because, yes, in other words, you've got to do that, because if you put .0800 in there, it's gonna give you another negative what? Z-score, because 3 is right here. What would 8 be? 8 would be right here. They don't want the bottom 8%. They want the top 8%, which means you got to find the negative 92% to find the top 8. So what do you get for 92? Should it be more than 1 and less than 2? Yes, I'll say 1.75 or something like that. What is it? Second bar is inverse norm, 0.9200. I'm sorry, what?
I think it's 141.
Well, that's fine. I just took a guess and said 1.75. 1 point what? 41. So that's your Z-score. There. Well, that doesn't help us, does it? Because it doesn't give us the numbers we need. Because this is negative 1.88. This should be 93 or something. So now we got to change it to what? Oh, it's plus mu. So x is equal to 5 times negative 1.88 plus 100. And I just said 93 just off the top of my head, but I think it'd probably be like 91. But what is it? And over here, x is equal to 5 times 1.41 plus 100. Well, that's going to be 5. It's going to be 7, around 107. What does it come out to be? Now you see why, what happens if you're not symmetrical. You have to go up and find the left-hand side of that one up there. So, 6 point, this right here is kind of like 6.2. That question where one's not symmetrical, this Z-score is not going to be the same as this Z-score. And then this is 6.3. I'm going to be changing it back into. All right, that takes care of that question. Find the indicated IQ score. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So, this one isn't that hard. They give you an area, so you've got to find the what? Z-score. He got mad and left. So this is 100, 115, 130, negative 85, 85, I don't know why I said negative. 85 and what? 70? Well, they don't give you nothing else. All they give you is 99%. So I'm going to take, since it's in green, I'm going to take my green marker, and I'm going to say, let's say this is full tank up here, so this is 2.5%, so this is 97.5 right here. So 99, I'm going to say is right in here, if it would work with me. So we know this is 0.9900. they give us an area, we gotta find a what? Say again? Please, switch this. What if I did that to y'all? What if I whispered up here? What would y'all do? Y'all would be pissed off. Why don't you speak up? Second bars. Let's say second bars. That's what I'm gonna start doing. I'm gonna start whispering. And then that's gonna be 0.9900. I'm sorry, what? 2.3263. Now, of course, if you did it in the table, it'd probably be 2.33. But somebody check in the table, see what you get for 0.9900. Okay? Thank y'all for your interaction. So, we're going to say this is 2.33.
That's exactly what you were saying.
Okay?
He's just putting them out, so.
Okay? So, let's go with 2.33. So we've got a z-score. So, what other formula is there? Odds plus mu. So, I forgot. 15 times 2.33, that's 30. 30 plus 100 is 130. It's going to be more than that. The 145. Somebody help me out. No. The 134.5, something like that. The 135.95.
It's
0.95. And that's your answer. Now it says round to one decimal place, so let's look and see what they have, because they may have that. Okay, there it is. That's what I've been wanting to show you. Now see, there's two numbers. Why is there two numbers there? Because one of them is calculated and one of them is with the table. One of them is calculated and the other one is with the table. And still, with both the problems, they still give you a 10th variance. So this could be 135 or it could be 134.8 or 134.9. 134.8, 134.9, 135. That's what that means right there. This could be 135, 134.9, 135, or 135 point what? 1. So you got 6 possible answers there. Okay? They're very lenient, and I'll be very lenient. Now, if the answer is 134.9 and you come up with 56, then I can't do much for you. Okay? But if you've got 134.92 and it marked you wrong, I'll help you out. I mean, I'll take that. I've never seen this problem before. Assume that women's heights are normally distributed with a mean blah 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 blah. Complete A and B. Okay, this is a 6.5 question. Is it not? Yeah, 6.5. So see, this worked out good because this is going to put us right into the questions we got for homework. Good. So, now remember what I told you. These right here, that right there is 6 point what? That's 6.3. And then this is 6.5. So let's do our problems like we've been doing. So we draw a picture. And that's going to be 63.9. And I have no idea. 65, 66.5. Might help me. 60. And then the next one is 69.4. Huh?
69.1.
69.1. And then the other side,
61.2.
and,
58.7.
all right. If I had one woman is randomly selected, blah, 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 between 63.7 and 64.7. 63.7 and 64.7. So we gotta change these 63.7 and 64.7 into what? That's right, class. So 63.7 minus 63.9 over 2.6. And then 64.7 minus 63.7 over 2.6. All right, somebody give me those two numbers. You don't have to tell me which one's which, because one's going to be negative, the other one's going to be what? Positive. They're
How many numbers?
just two decimal places, z-scores,
Okay, negative 0.08.
0.08. And this one is I'll say it's gonna be around 1 point. No, it's gonna be like 1 point. No, be like 0.15 or something. What? Okay, point what? 38?
Yeah.
Yeah. Now, take your handy dandy calculator, and the reason I'm doing the calculator here is because it's easier to find the in-betweens with a calculator. So do your, whatever it is it normal, CDF, whatever it is, from 0.08 to 0.38. So which one is it? Second bars. Y'all got to remind me which one it is. With normal CDF, and then from negative 0.08 to 0.38, somebody give me that number.
0.1799.
17 what?
99.
And that should be, no, that's the wrong answer, because it has a little red spot. Let's see what the right answer is.
It is right.
Of course it is. No, it's not.
That one is
We've done something wrong. All right, that means y'all have done something wrong, because I only did what y'all told me to. I got to blame it on y'all.
okay, on the second thing, is it not 308 instead of 38? I put this up,
All right, so it's not entirely wrong. I just misinterpreted y'all's whispers. Sorry. What is it? Point what?
308.
That would make a difference. Yeah. Now,
I may not be right though.
I think that's right. Because I don't think we'd get it. So somebody do second bars, normal CDF, 0.08 to 0.31. See what you come up with. What do you get? Good job. Way to go, Miss Cowart. You saved the day. Don't talk too loud. Make sure you whisper. That way I can mess up another problem. All right. If 20 women are randomly selected, find the probability that they have a mean height between 63.7 and 64.7. So are we using the same 63.7? So all you have to do, instead of dividing by the mean, the standard deviation, you divide by the standard deviation divided by the square root of 20. So the square root of 20 is going to be around 4.5, is it not? Yeah, 4.5. Somebody check, what's the square root of 20? It's a miracle. So, let's get this down a little bit. I don't know. Oh my gosh, it doesn't. Wow, never done that before. Okay, so let me move this up a little bit. So that's that. Now, instead of doing these two with 2.6, you're going to do the same thing. You're going to say 63.7 minus 63.9 divided by 2.6 divided by the square root of 20. And then you're going to do the same thing with the other one. 64.7 minus 63.7 over 2.6 divided by the square root of 20. And the square root of 20 is 4.5. So, you're going to take 63.7 minus 63.9, that's going to be negative 0.2, right? Over 2.6 divided by 4.5. And then over here, you're going to have, that's 1 over 2.6 divided by 4.5. Well, that's 3 divided by 5, which is 6/10. So that's negative 0.2 divided by 0.6. And that's going to be 1
Priority
divided by
message coming in on
0.6.
secured channel.
And 0.2 divided by 0.6. That's 2/10. I'm thinking out loud, so y'all just bear with me for a minute. 0.6. Oh, go ahead. Tell me what it is. What's 2.6 divided by 4.5? Okay, 0.6. And then take 0.2 divided by 0.6. What do you get? Just use 0.6. I'm not worried about it. Negative what? Or take 0.2 divided by 0.58. I don't care.
You said divided by 0.58.
Yeah. Negative 0.34. Everybody get that? And then take 1 divided by 0.58. What do you get?
You get
1 point what?
1.724.
Now, take your inverse, take your normal CDF and go from negative 0.34 to 1.72. And tell me what you get.
You get 0.5934.
Point what?
5934.
Okay. Well, we're off a little bit, but I'm not worried about it. I don't know if that's right or not. I don't see a little.
Yeah, it is.
It is. You got point what?
5904.
Okay, so there may be a little bit of error. Y'all check the math. I don't know if I've got an error there or not, but y'all get the point. The first part is 6.3. That's this part right here. That's finding these. And then 6.5. And what's the only difference? Instead of dividing by 2.6, you're dividing by what? 2.6 divided by what? Square root of 20. Now, this is less than 30. The 20 women, but what does it say right here? Normally distributed, so therefore it does If that didn't say normally distributed, then you got a problem. That's it. What did you do? Did you find the error?
Yeah, we wasn't supposed to divide by one, we supposed to divide by 0.8.
Where,
For the second part. It's
Oh.
supposed to be 0.8 divided by,
oh, this is 64.7 minus 63.7?
yeah, it
I thought that was negative 1, or
was
1.
0.8. I just did it in the process.
Okay. 1/8. I thought that'd be 1. Or maybe, maybe I'm just doing too much math today. 5493. Okay? And that's supposed to be 0.8 divided by 0.6 or whatever. Okay? All right, now let's jump off from that and go into 6.5 questions from homework. Of course, they logged us out because I'm about the only teacher that uses email in class, so. Let's see, that's my instructor. All right, that's 6.5, 6.5, 6.5, that's 18. Let's see, that's 7. This is where I do all y'all's homework for you. Yeah. 7, 8, and 9. So, yeah. This is number 7. And it disappeared. Okay? Women have pulse rates that are normally distributed with a mean of 72 and a standard deviation of 11.1. Okay, go ahead and draw your picture. That's your first percentile and your 99th percentile. Actually, they're symmetrical.
Okay, so.
But it's probably going to ask you B anyway, so we got to go over it. Y'all got to check my math. And then I want you to draw the percentages in there that they want. In other words, the shaded area. So I want you to draw the shaded area. The first percentile and the 99th percentile. All right, so you know that this is 2.5% right in here. So the first percentile would be right in here, maybe. You know, agree with me? Because half of 2 is, so if we were doing half, that'd be around 1.25, so, but we just say 1. So 0.0100. And then the 99th percentile would be right here. Meaning that all of this area right here is point what? 0.9900. From there to there. So they want to find those numbers. So, we got to find the z-score. I'm going to find the left one because that'll be the easiest one to find. So, second, bars, inverse norm of 0.0100. Somebody tell me what you get. Negative what? 2.33, and what's the top one? 2.33. So that's this one. And this one is right here. Well, we have a z-score, but that's not what they want. What do they want? They want x. So odd plus mu. So standard deviation is 11.1 times negative 2.33 plus 72.7. Negative 22, be around 60, I'm sorry, 50. Around 50 beats per minute. What is it? 46.837. That's your first number, round it accordingly. And then the second one, x of 2 is equal to 11.1 times 2.33 plus 72.7. What do you get? Again, 22 would be 93 beats per minute. What does it come out to be? That's all right, I'll wait. Say again?
98.5.
And that's your two numbers. Y'all know how to use Oz plus mu now, don't you?
Why is it 2.3?
Because it's symmetric. Look. What's the percentage right here? 1%. All right. What's the percentage at the 99th percentile? 1% on the right here. So it's symmetrical. We did those problems a while ago where I told you if they're symmetrical, see, when they say 99th percentile, which way do we read? That means everything to the left is 99%, so that means everything to the right on the blue is what? 1%. See, they're symmetrical. 1%, 1%.
So what did I say?
P1 is equal to 40, what did it say, round to one decimal place? 46.8. And 98.6. It's amazing. All right, knock yourself out. This is 5.6.5. Really, you don't need the chart here, do you? You just need z-scores. So z sub 1 is equal to 35. I'm sorry, 54. What was the mean? 72.7. over, hold on, let me, oh, yeah, 11.1 divided by the square root of 35. Well, just hold on a minute before y'all start punching. And z sub 2 is equal to 92 minus 72.7 over 11.1 divided by the square root of 35. Well, we all know that the square root of 35 is 5.9, right? So z sub 1 is equal to 54 minus 72. Oh my God, we're being attacked. Divided by 11.1 over 5.9. And then z sub 2 is equal to 92 minus 72. That's dang old 20, so it'd be 19.3. 19.3 over 11.1 divided by 5.9. I gotta figure out what this is. So 54, big dang old 18 point something. I don't know, 18.3, 17.3. What's 54 minus 72.7?
Oh,
Negative what? Okay, I said 18.3, sorry. Negative 18.3, so I'm going to take that out. Negative 18.3. Or negative 18.7, is that what you said? Okay, what I'm trying to do is I'm trying to get it down to a point where I can do it in my head, just to see if I can get it close. And I do things like this. I'm weird, okay? This is what I do. All right, so 18.7, that's 19. So I'm going to say z sub 1 is equal to negative 19 divided by an 11.6. That's 12 divided by 6 is 2. So I'm going to say this one right here is around negative 9.5. And then this is going to be 19 divided by, let's see, well, technically that's not 2. Why did I get 11.1? Is 11.1 or 11.6? I did it again. There I go, doing it again, changing my numbers. Sorry. Well, then it's not going to be divided by 2. It's going to be divided by 6 into 11, be 1 point something.
It's negative 9.97.
Okay, so I'm not quite that far off. And then this one is going to be 19 divided by 2, which is going to be equal to 9.5. I'm going to say 9.9. And this one is negative 9.9. Y'all check it. Did y'all get 9.9? You up there? Okay.
Yeah, maybe.
280.
Oh, because 20 divided by 2 is 10. What'd you get?
10.22.
Okay, 10.27, I'm sorry. 10.27, or 10.3. And what's this one? Negative 9 point what? What did you say this was, Ms. Coward?
Which one?
This one, negative
9.97.
9.97 would be negative 10. All right, now, we just got to find the probability between these two z-scores.
We gotta do what?
Find the probability between those two z-scores. So somebody do inverse norm, I'm not inverse norm, do normal CDF, or whatever it's called, from negative 10 to 10.3. It's going to be like 99%. Okay, I said 100%. Those don't seem right. Those are some awfully high numbers unless we're doing something wrong. Probability is 1 for 0.9999. Yep. Okay, now it's for a get the problem wrong question.
If the doctor wants to select pulse rate to be used as cutoff values for determining when further tests should be required, which pulse rates are better? The result from Part A or Part B? Well, it says, let me see what the first one says. It says, women have pulse rates that are normally distributed, blah, 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 blah. Doctor sees exactly 35 patients a day. Find the probability that 35 be blah, 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 blah. I would say B, because it's actual people. But you think they're going to say that? No. It says, well, 0.999, they don't give you one in the table. If you're doing by the table, you're only going to get 0.999. All right, if the doctor wants to select maybe B right here, C. But there also is a chance that they're going to say that the mean both rates are equally acceptable because this is 0.9999. So I would take C or D. Got A. Okay, tell me why. Because the cutoff values should be based on individual patients. Well, I thought that's what that meant right here. Wait a minute. Part A, that's on the sample. I want you to be able to do the math, okay? Yep, but A is from a sample. It doesn't say where the sample is from. So it says women have pulse rates that are normally distributed. Where did they get that from? Where did it come from?
What is that thing that they got where they check it right? It says on an individual patient rather than the mean pulse rate of the sample.
Well, this is the sample. The Part A is the sample. It's saying Part A. Where does Part A come from? I think the answer, to me, what would you rather have? Would you rather have a sample or would you rather have your doctor's patients? Would you rather have your doctor's patients' data? I'm not going to go there. But anyway, I would say the answer is B. Should be based on individual patients rather than the mean pulse rate of a sample. Now, how could I change this? If I said your doctor or the doctor that they're talking about here have pulse rates that are normally distributed, then that would mean that the sample is coming from the same one, doctor. So then you could argue, but that doesn't say that here. This would be coming from Doctor's Monthly Magazine. You don't know where this is coming from. So I'm not going to put much. If you get that wrong, just let me know, and I want you to be able to do this right here. Okay? Is that what you had a problem with? You got this right, didn't you?
Because like on the test, when we have stuff like this, I always get the question.
Well, you need to let me know, because I'll fix it. Because that's, in my opinion, this is not correct because you don't know where the sample comes from.
And then you get extra practice on it trying to get it right because you got the questions shown wrong.
Yeah. So, I'm sorry. That's one of the reasons we changed in the book.
Oh, we don't have to go to the other questions then.
Well, I don't mind doing it. Is it the same questions or what?
I can't remember, but I think they are.
Well, we'll see. This is 8. All right, we can do this one. That's fine. An engineer is going to redesign an ejection seat for an airplane. The seat was designed for pilots weighing between 120 pounds and 181 pounds. The new population of pilots has normally distributed with a mean of 129. Okay, so draw your picture.
All right, so 129. Why can't they do 130 and 30 pounds? Why do they have to do? Ooh. All right, give me these two numbers. Be 131. I'm trying to do it in my head.
You get 162.
Thank you. 162.5 and
196.
even. All right, back.
95.5.
95.5.
Sixty-two.
All right, and they want, the seat was designed for pilots weighing between 120 and 181 pounds. So 120 and 181 pounds. Okay, so find that probability. So 120 minus 129 over, what's the standard deviation? 33.5. And that'll give you that one. And then 181 minus 129 over 33.5. And that'll give you that one. So what's this Z-score over here? That's what I heard. Two things, volume and enunciate.
The first one is negative
-.2686. 26 what?
0.2686.
All right, or -.27. Everybody get that? Okay, comma, so this is what you're going to put in your normal CDF. And what's this one? 49, what?
You get 1.552. Yeah.
1.55, that's good enough. All right, now put that in your second bar's normal CDF and somebody give me that probability. Four decimal places.
0.548. I meant 58. 0.5458.
5458. Now, does that make sense? Well, look, you got 34% here. You got half of 14 here. That's 7 plus 34. That's 41. And then you got some here. So that technically could be close to 50% because you got 41% on the right side. So let's type it in. 0.5458. And we feel good about ourselves. Now what does it say? It says, if 32 different pilots are randomly selected, blah, 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 blah. So, you don't have to do much. All you got to do is erase this part right here. So, everybody got this down? I'm going to take my handy dandy eraser and I'm going to erase this. And I'm going to erase this. And I'm going to put, instead of 33.5 on the bottom, what is the square root of 32? Well, the square root of 32 is going to be about halfway between, so it's going to be around 5.4 probably. What is it? 5 point what? 5.7, okay. So that's going to be divided right here of 33.6 divided by, what'd you say, 5.7? And
It's
30,
32.5.
33 point, thank you, I'm just changing the problem here. Divided by 5.7. And I'm just going to let y'all do this and tell me what this number is over here. I'm sorry, say 5.92. And then this one, that's negative, right? Why you setting me up, Miss Josie? Why you
One
doing
point
that?
52.
Huh?
1.52.
1.52. Negative?
Yes, sir.
All right, and then what's this one?
Okay, I got 8.858.
Everybody get 8.86? Hello?
Yes.
All right, now give me a probability between negative 1.52 and 8.86. 0.9307, 57. That's 94%.
0.9357. Okay. Did we get it? Now, time to get the problem wrong. When designing the ejection seat, which probability is more relevant? Now, it says if a pilot is randomly selected, find the probabilities weight between blah, blah, blah. If 32 different pilots, an engineer is going to redesign an ejection seat for an airplane. The seat was designed for pilots weighing between 120 and 181 pounds. That's what the seat was designed for. A new population of pilots sounds like a new species of pilots has normally distributed weights with a mean of 129 pounds. Walter, please stop. Part B, because the seat performance for a sample of pilots is more important. Part B, A, because the seat performance for a sample. Part B, because the seat performance for a single pilot. How do you say more important? In this case, I would say the sample. Well, this is the sample right here, and this is the individual pilots. So, right here. You see why I don't care?
It says reason one for it.
Excuse me, again. Okay, if a pilot is randomly selected. Okay, again, I will take these two answers, and I'm not worried about this because these make no sense to me whatsoever.
So just click anywhere.
Huh?
Just click anywhere.
I mean, honestly, it just... Sorry about that. And 9, last one. An airline carries 200 passengers and has doors with the heights of 72 inches. Heights of men are normally distributed with a mean of 69 inches and a standard deviation of 2.8. If a male passenger is randomly selected, find the probability that he can fit through the doorway without bending. So, draw you a picture. You leaving us?
Yeah, I'm right,
You done got mad and discouraged?
No.
Have a good day. See you Thursday, or whatever day y'all come next. All right, let's see. 72, no, 69,
And I'm just gonna add 3 people, I'm getting tired of the decimals, so that'd be 72 and 75, and then 66 and 63. And they wanna know, heights and men are normally distributed. Okay, door is 72 inches. If a male passenger is randomly selected, find the probability that he can fit through the door. So that'd be this one, right? Because 72. Okay, make sure, what's 69 plus 2.8? Okay, so this is 71.8. So it'd be a little bit past this. 72 is right there. Y'all see what I'm doing? That's 71.8. So there we go. Y'all with me? All right. So somebody do 72 minus 69 over 2.8. And then give me that z-score.
1.07.
1 point what?
07.
So negative 9999, 1.07. Somebody give me that probability. Give me 4 decimal places. I think I've lost Remy. He's gone. He's already put up everything. You can't hang no more. Well, we almost finished. And that's right. I don't think we'll have problems getting them A and B right. If half the 200 passengers are men, find the probability that the mean height of 100 men is less than 72. So instead of dividing by 2.8, you're going to divide by 0.28. Okay, I'm not going to go through that math because everybody should know that. So take 72 minus 69 and divide by 0.28. And somebody give me that z-score. So 9999 negative to what?
I got 10.714.
10.714, which I can tell you what that is. It's 0.9999. So 0.9999. How did I know that? Well, any score above 3.5 is 0.9999. So, and you know this is, so it's 9999. When considering the comfort and safety, which result is more relevant? I'm surprised I didn't use more important. The probability from part A or B? I'm going to say A. I'm going to get it wrong. Because it shows the proportion of male passengers, shows the proportion of flights. I have no earthly idea. That's the one you should go with. The one you have no earthly idea. All right, that's it. Y'all got it? Don't worry about these. I don't want... What the heck? When considering the comfort and safety of passengers, why aren't women ignored in this case? Because the airline does not care about women. Because women do not get up to 69 inches, I assume. How about this one? Wait a minute. I would say C. Yes, ma'am. Anybody else got any? I think we went over enough today.